How AI detects cannabis plant diseases before humans. Welcome back to the AI Smoke session. Imagine being able to detect a cannabis plant problem before a grower can clearly see it with the naked eye. That is exactly where artificial intelligence starts to become powerful. In this video, I'm going to show you how deep learning can be trained to recognize disease patterns in cannabis leaves using a real dataset, Google Colab, and TensorFlow. So instead of only talking about AI and cultivation, we're actually going to build part of the system. Let's get into it. The first step is the dataset. For this project, I'm using a cannabis leaf disease dataset organized into folders by class. Each folder represents a different plant condition. In this case, the classes include spider mite infestation, powdery mildew, rust fungi, and nitrogen deficiency. This is important because deep learning image models need labeled examples. That means the model has to see lots of images that already belong to known categories, so it can learn the visual differences between them. To set this up, I'm working inside Google Colab, which is a cloud-based notebook environment that makes it easy to run Python and deep learning code without configuring everything locally. After connecting Colab to Kaggle and downloading the dataset, the next step is to point TensorFlow to the folder that contains the disease categories. Once that path is set, TensorFlow can automatically load the images directly from the directory structure. In the code, I define the image size as 224 by 224 pixels and choose a batch size of 32. That means the model will process 32 images at a time during training. Then I use TensorFlow's image dataset loader to split the dataset into training and validation sets. The training set is used to teach the model, while the validation set helps us measure how well it performs on images it has not seen. After loading the dataset, I print the class names and preview sample images. This is a very important step. Before training any model, you want to make sure the images are loading correctly and that the class labels match. At this point, we can already see the different cannabis leaf conditions the model will learn to recognize. Now we move into the deep learning part. Instead of building a model from scratch, I use a technique called transfer learning. Transfer learning means starting with a pre-trained neural network that already understands general visual patterns like shapes and textures. For this project, I use MobileNet v2 as the base model. This gives us a major advantage because the network already knows how to extract useful visual features. We are adapting it for cannabis leaf disease classification. Before the images go into the model, I also apply data augmentation. This means images can be randomly flipped or rotated. That helps the model generalize better. In a real environment, leaves won't always appear at the same angle. Next, I freeze the base model so its pre-trained weights do not change during the first training stage. Then I add a custom classification head on top, including global average pooling and dropout to reduce overfitting. Once the model is built, I compile it with the Atom optimizer and accuracy as the main performance metric. Then the training begins. This is where the model starts looking at batches of cannabis leaf images, comparing its predictions to the real labels and adjusting its internal weights to improve over time. As the epochs progress, we can track both training accuracy and validation accuracy. We want to see accuracy improve. This is one of the most exciting parts because we can literally watch the AI get better at identifying conditions. After training, I plot the training and validation curves. These graphs help us understand if the model is learning well. For an even stronger result, I can also fine-tune the model by unfreezing part of the pre-trained network. This allows deeper layers to adjust specifically to cannabis leaf disease features, making it more specialized. And this is where the bigger picture starts to matter. For growers, this kind of system could become an early warning tool. Instead of waiting until a problem becomes severe, AI-assisted monitoring could flag symptoms much earlier. A model like this could eventually be connected to cameras in a grow room, scanning leaves continuously. That means earlier intervention, healthier plants, and less crop loss. The concept is very real. We're training a deep learning system to recognize visual signals, and that is the foundation of AI-driven plant health monitoring. This is how artificial intelligence begins to move from theory into practical cultivation technology. In the next step, we can go further by generating heat maps that show where the model is focusing its attention on the leaf. That helps make the AI more interpretable and gives us a better understanding of why the model made a specific prediction. And that is where things start to get really interesting. This is the beginning of a real AI grow lab workflow. If you want to see more videos where we combine machine learning and cannabis cultivation, subscribe to the AI Smoke Session. Until next time, stay curious, stay informed, and keep exploring the future of AI.